Let's double-click the green GL icon to launch Quick Look. This is the main menu of Quick Look. We have a video training for the first choice of continuous beam program. The next three are AISCWSD design, ACI concrete beam design, and ACI column design. All of these three programs are dialogue driven. Simply fill in the blanks and ask for results. The input is self-explanatory for any civil or structural engineer. Let's click the Solution Manager. The first tab page is Section. This is the place to manage the customized section property library. The next one is to update the customized material libraries. Next, change the color scheme of the graphics. Finally, change the default topic and its corresponding content of the summary report. Back to the first tab page of Section. Before we proceed, let's bring up a slide. A member connects from its starting joint to ending joint. Among these two, which one is the starting joint? It depends on the coordinates of the two joints. 1. The joint with lesser x coordinate is the starting joint. 2. If x is equal, the joint with lesser y coordinates is the starting joint. 3. If x and y are equal, the joint with lesser z coordinates is the starting joint. For example, the starting joint of member number 12 is joint number 9, lesser x coordinate. The starting joint of member number 13 is joint number 7, also lesser x coordinate. The starting joint of member number 10 is joint number 4, x coordinate is the same, lesser y coordinate. The member's local x-axis is from its starting to the ending joint. How about the local major and minor bending axis? 1. The local coordinates are axes y and z. 2. The major bending moment of inertia is Iz and the minor bending moment of inertia is Iy. 3. Iz is always equal or larger than Iy. In the definition of the customized section properties, Quick Look enforces this rule. 4. In order to calculate major bending stress, the value of elastic section modulus Sz must be present. Otherwise, Frame Builder will not report the major bending stress. 5. For 3D structure, in order to calculate minor bending stress, the value of the elastic section modulus of Sy must be present. Otherwise, Frame Builder will not report the minor bending stress. For 2D structure, the major bending moment of inertia is the default in the analysis. If the member rotated to use the minor bending moment of inertia in the analysis, please specify the beta angle of the member to be 90 degrees. 90 degrees beta angle tells Frame Builder to use the minor bending moment of inertia in the analysis. Close the slide. Let's go back to the tab page of the customized property library. To the right of green number 1, there is a list of tags of the previously defined customized sections. Select block 2x4. The dialog box is updated. From the top, green number 1 has the tag of block 2x4. Green number 2, the unit is inch. Green number 3. The sub-tab page of rectangular is loaded, indicating this is a rectangular section. To the right, the definition of B, D, and T are displayed. In this case, it is a solid rectangular block of 2-inch width and 4 inches height. Below the blue commit button, there is a line displaying the calculated properties. Once a tag is defined and saved, it is available to both Frame Builder and continuous beam calculations. If you want to update the property of this tag, go to green number 3, change B from 2 to 2.5. For green number 4, click blue button Commit, check OK, to confirm. Finally, next to green number 5, click the disk icon, to save the update. If you want to add a pipe, its OD is 5 inches, ID is 4 inches. The easiest way is to select an existing circular section, change its tag, modify its dimensions. Let's select pipe 4x3, the sub-tab page is now changed to round and populated with the parameters of pipe 4x3. For green number 1, change tag to become pipe 5x4. Make its OD 5, its ID 4. For green number 4, click the blue commit button, click OK, to add a new pipe. Scroll down the list, pipe 5x4 is at the end of the list. Finally, next to green number 5, click the disk icon, to add. To remove a tag from the library, double clicks. Select pipe 5x4, double click it, click OK, to confirm. Pipe 5x4 is now removed. To save the changes to the library file, click the disk icon next to the green number 5 button. Next, let's manage the customized material library. Go to the top, click the second tab page, Material. To the right, the customized material tags are displayed. The procedure to work on it is similar to that of the section library. Here, we have 3 materials. If we want to add an A40 steel to it, because the properties of A40 steel is almost identical to that of A36 steel. Let's select A36 from the list. The dialog is now updated with A36 steel properties. For green number 1, change A36 to A40. Use the same entries for green number 2. For green number 3, make some minor changes on E and density. Click number 4 commit, then, yes, to add. For number 5, click the disk icon to save. Now A40 steel is available to be used. If you want to remove A40, double click it, click yes, to confirm and click the disk icon to save. That is all.